All right, sixth grade. I want to work through a second problem dealing with mean absolute deviation. Hoping the first video helped, but here's a second video as well. Here's a problem from a problem set on Khan Academy. It says the following table shows the number of points scored last basketball game by each player on the Dragons basketball team. So here you see the data table, and I'm going to represent it visually down here on my paper. So we have 5 points scored, so I'm going to put that here. 5 points. 8 points scored. I'll put that over there. 8 points scored. We have 11 points scored. That'll go at the end over there. 7 points scored. And lastly, 9 points scored. So looking at this visually, what would the center be? What appears to be the center of this data set? But of course, we don't have to rely exclusively on how it looks. We can use math to actually calculate our center or our mean. So the way we do that, once again, is you take every piece of information in our data set, and we have 5 different pieces of information. We have 5, 8, 11, 7, and 9. We add that up. So I'm just going to do some mental math. We have 8 and 13, 24, and 16 makes 40. 40 total points, hopefully my math is good, I should be, divided by 5 actual pieces of data. 40 divided by 5 is basically asking how many 5s make a 40. That is 8. Our mean is 8. That should also be defended or proven, I should say, proven by what we see visually. So is 8 about the center of our data? Yes, 8 appears to be right in the middle, so that makes a lot of sense. So our mean is 8. But when we're dealing with mean absolute deviation, we need to know a little bit more than the actual mean. We need to also consider how far is each of our points from our mean. So just looking over here at the 5, how far from 8 is 5? That's 3. Our next data point is 7. That's a lot closer. How close or how far is that from 8? That's just 1 away. The 8 is not far from 8 because it's 8, so that's simply 0. Our 9 over here is 1 away from 8, so that's 1. And our 11 out here is 1, 2, 3 away from our mean, so that's 3. So now that we've done that, add these numbers up. 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 3 is 8. But we divided by how many pieces of data we have within our set. So 1, 2, 3, 4, 5. Divide 8 by 5. How many 5s make an 8? That's 1. We've divided 5 out of the 8 with 3 remaining. 3 over 5. If we're pretty fluent with converting fractions to decimals, 1 3/5 is the same as 1.6. So let's go over to our practice set, put in 1.6 and see what happens. And we got it right.